Yeah, the other day I had asked you people to draw the three-dimensional structure of propane and hexane molecule. I hope you remember that. We have written, okay, you can see on the board, this is what we have stopped last time. Now let us see how to draw the propane. See here, propane is having this structure, CH3, CH2, CH3. And I told you, whenever you draw a sp3 hybridized carbon, CH3 and CH2, sp3 hybridized carbon means with no double bond. They should be drawn like this. Like this. Oh, sorry. I'm not getting the control. Then, then here, again at 120 angle, I make all of them should be at 120 to each other. Okay, now H, then this one will become our wedge bond. So these are the H, and now down we have this wedge bond. And now you have one more carbon. This is carbon number 1. This is 2, and this is 3, propane. And that becomes the wedge. See this. H, and H. So this is propane. This is propane. And also you can draw this extent to any number of molecules. See here, 1, 2, 3, 4, 5, 6 carbons. Okay, on each of these you can draw hydrogens, hydrogen here, hydrogen here, and hydrogen here. H, again you can draw a wedge here, along with you can put 2 hydrogen behind. Again H is here, then H is here. See, you can draw any number of carbons over here. Any number of carbons can be put on this. So this is the 3-dimensional structure of hexane molecule. Now I want you people to, yesterday I had shown you, you can look at this figure. Here is ethane molecule. We are drawn in the other day. Now I am holding this ethane molecule in this direction. And I'm holding a torch here, applying light on this side. And then how will the shade of this fall on this wall? I'm holding it against a wall. This is the wall. And now I am applying light on this side. If I project it, if I project the shade of this molecule on the wall, how will it look like? If I'm holding the molecule like this. And also, here also, if you are applying the wall, if you are applying the torch, how will this molecule look like? Let us look at the first molecule. Why didn't you draw by yourself? Yesterday I had asked you to draw it. Second one. Let us look at the first one. See the first. Can you observe? Just observe it and tell me. See, you are looking from here. Your eyes you have kept here, looking in this direction. From here to here, you are looking. So when you look at that, you can see this hydrogen. Say this, these are the two carbons. If I mark, and if you look from here, you will see only one carbon. One carbon only you will be able to see. This carbon you can see. Behind carbon is exactly behind this carbon. Okay, good. Now what did I do? No, so that carbon I'll mark like this. The front carbon I will mark it like this, a big circle. Then you can see this hydrogen is on your right hand side, and that is up. Up means, suppose this is the horizontal line, the bonds in this line above this horizontal line are called up. The bonds above the horizontal line are up. So let me put that bond here. So that is on my right hand side. Now the one on the left hand side will be this one, and that is this one. Okay, and now see, this bond is pointing down. This bond is pointing down, exactly down. Oh. Pointing down. Now let us look at the bonds behind. The one which is up. The one which is up is this one. If you look from here, this bond will be exactly between the two bonds here. It is exactly between the two bonds here. So I'll put it here. Okay. Now we have to mark these two carbon, these two hydrogens. And see here, this one is on the right hand side. Here, it is pointing down. This one is on the left hand side. Okay, so that is what how it looks like here. And now, if you draw the same thing here on this molecule, on the second molecule, what you get is a circle which is representing the first carbon, and then see this hydrogen and this hydrogen will be in a single line, along a single line, vertically up. So let me put this first, and this hydrogen is just behind this hydrogen. So we will write it just like we have drawn the dotted line. We will write it very close to each other. Okay, it is very, very close to each other. Then you have on your right hand side the dotted line in that structure. Oh. And on the other side we have this. The angle is not perfect. Okay, bear with me for that. Now you can see this hydrogen and this hydrogen are projecting outward towards us. Okay, these two hydrogens are projecting towards you. And both of them are one behind the other. Okay, both of them are one behind the other. Okay, so now here also you have, sorry, I'm trying to draw simple lines only. And remember, in this representation, there is no wedge or dotted line structure bonding. Do you know why? Any one of you can tell me why is no wedge bond or dotted line structures are used in this type of representation of the molecule? Why there is no wedge and dotted line? The reason is we are not actually looking at the molecule as such. We are looking at the projection, the shade you get on a wall. And all the bonds on the shade, all the bonds, all the CH bonds will be planar. So all these at least in one plane or in a parallel plane. For example, you think about this carbon and think about the carbon behind. All of them are not in a single plane, but the projection is in a single plane. Applying the torch, you get what figure you will get, that is in a single plane. So this type of representation is called a Newman projection. Okay, so this is called a Newman projection of the molecule. So you can see here, and in the Newman projection, this is called a staggered conformation. And this is eclipse conformation. Staggered and eclipse conformation. Okay, now, so now let us look at the next molecule. That is our familiar C2H4. We are familiar with this molecule, that is CH2 double bond CH2. Okay, now hybridization is sp2 hybridized. How do you know whether a particular carbon is sp2 or sp3 hybridized? How do you know? It's rather very simple. If you have a double bond, if you have no double bond, if there is no double bond, it is sp3 hybridized. If you have one double bond, if you have one double bond, it is sp2 and two double bonds, or a triple bond. Or a triple bond. It is sp. Now here you can see you have only one double bond. So the geometry is sp2 hybridized. And the sp2 hybridized carbon is a trigonal planar. You should remember, in deciding the geometry of these molecules, we consider only the sigma bonds. That is something which I remember. Okay, geometry is defined by the sigma bonds or hybridized orbital bonding. Hybridized orbital bonding. But the unhybridized orbital in this, which forms the pi bond, will lie in a plane perpendicular to the plane of the sigma bonds. Okay, so that is what we are trying to bring here. Okay, now let us look at ethylene molecule. Okay, you have CH2, then there is a CC bond, then there is a H bond. Tell me the geometry of this carbon. All these you can see here, this is trigonal planar, it's also trigonal planar. So all the carbon, hydrogen, all of them are in a single plane. All are in a single plane. All of them are in a single plane. Right. Now once you draw this, now we have to draw the p orbital here. Okay. Now before I draw the p orbital, for a better understanding, just observe from here. Suppose I keep a rod here along this one which is coming out. This is a rod. Suppose you are rotating the whole molecule 90 degree along this axis. 90 degree along this axis out of plane. What figure you will get? What you have to do? You hold it, hold the long rod over here, and 90 degree clockwise you rotate. Clockwise 90 degree you rotate. Okay. Now that means this is now above the plane, above on the plane of the board. Now when you rotate it 90 degree, this will go back. So you will get and this will come to the front. Okay. So this is coming to the front. Same way here also. Yes. So now you can see all this. This whole, all the sigma bonds in the plane of the board. But here they are in the perpendicular plane. This is projecting out towards you. This hydrogen is also projecting out towards you. The other two are behind. Now we have to draw the orbital. Right? So this is how the three-dimensional structure of ethylene molecule look like. Many of the textbooks will give this type of presentation. Sorry, one second. Yeah. They are all in a single plane. Now you have drawn the two orbitals. Here they form a pi bond. And now if you rotate this, how will you draw the pi bond here? How will you draw the pi bond? How will the pi bond look like? Can you try to draw the orbital on this figure? Now you will have a difficulty, definitely. What you can do is, you can just look at this. Now draw what you are seeing from the front. Draw this. Don't draw my hands, only the pen. Now let me see what I'm doing. Look at what I'm doing. I'm rotating it to the front. See here. Now draw it. Again draw it. Again draw lastly. How will you draw it? Okay. Now see, initially you were seeing this way. Initially the pen was like this, all along. After some time, and now when you rotate further, see the vertical nature will not change. It will not change. It will remain as such. But the thing is, it becomes shorter. It becomes shorter. Now again it comes here, still shorter. And ultimately, you will not see anything. Okay? Till more you rotate it, it will be appearing as this one. See, it is the same thing which is happening. If you rotate this orbital, okay, 90 degree, you will be able to see only this place. Okay? So, the drawing of this p orbital in this structure will be like this. One unhybridized p orbital, a second unhybridized p orbital. That's clear? So this is how you draw the structure of ethylene molecule. Of course, you have to remember, if you represent this way in the book, you will people will find it difficult to understand. That is why what they do is they put a three, that is they draw it in a different way. You must have seen the textbook. Many of the textbook they contain and then you have okay. So many of the textbook will show like this here. This is how they put the bonds. I will never suggest you to copy this down. This is absolutely wrong. It's not correct. And then what they will do is they will put a orbital here. Okay, that doesn't make sense. Either it is this way or it is this way. One of them you have to represent, and you should be able to draw the geometry of the model. Now, in a similar way, you can do with acetylene molecule also. You can generate acetylene molecule. Remember, you have two pi bonds in acetylene, mutually perpendicular to each other. Okay, mutually perpendicular to each other. So that is how you draw the basic structure of molecules. So next time we'll go into different types of compounds and the basics of all those things. Okay, thank you.